Hello dear friends, welcome to the lecture of real analysis. In this lecture we shall study functions, definition of function, then types of function and some theorems relating to the inverse image and also image of a set under a given function that we are going to study. And to save the time, I have written the definitions here. These are simple to understand. We shall see the meaning of these definitions. To define function, first we shall define what is a Cartesian product of two sets. Here is the definition for if A and B are sets, then the Cartesian product of A and B, which is denoted by A cross B, is the set of all order pairs AB where A belongs to A and B belongs to B. So the meaning is simple. A cross B or Cartesian product of A and B is the set of all order pairs A comma B, where the condition is the first element belongs to the set first set capital A and the second element belongs to the second set, that is capital B. So B belongs to B. So this is the meaning of Cartesian product of two sets. And for example, if we consider A as the set consisting of two elements X and Y, and B is the set having the elements 1, 2, 3, then how to form the Cartesian product of A and B, which will be A cross B by this definition. Select an element from the first set and an element from the second set and form all such possible combinations. So that we have fixed first X, and then the order pairs will be X1, then X comma 2, and then X comma 3. So the pairs with first element X are all written. Then we consider the second element of the first set as Y and take the elements one by one from the second set B. That is Y comma 1, then Y comma 2, and then Y comma 3. So these are the Cartesian, this is the Cartesian product of the two sets A and B, where these are the order pairs of the elements from A and from B. So this is the meaning of Cartesian product. Now we shall define function. So function is defined in terms of Cartesian product. Earlier we know function can also be defined as a relation between two sets or elements of two sets, such that element from first set, every element from first set is related to an unique element from the second set. But instead of that way of defining the function here is defined in terms of Cartesian product. Let A and B be two sets. A function f from A into B denoted by this notation f, small f, and it is function from A to B. So this is notation for a function, and this is a subset of A cross B, such that, and the condition is such that each A belongs to A, the element from the first set belongs to precisely one pair A comma B. So that is the meaning of the function. That means every element from the first set is related to unique pair, or that gives unique pair or exactly one pair A comma B, and such relation is defined as function. So for example, the earlier definition of function that we know is if this is the set A and this is the set B we have considered, then every element of this set A, if it is X, that is related to an element of the set B, and this must be related to unique element and cannot be related to more than one element, and that's why it is written precisely, means exactly one pair A and B. So then we write, if this is the order pair, then what will be the order pair? X comma Y will be the order pair, and that belongs to the function f. This is the function f from A to B. Then we can say X Y pair belongs to f, and we write this as Y is equal to f of X, and then we call Y is, this is image of X under this function f, and the set A is called domain of the function. And see, we can note that this x cannot be related to two elements. Suppose there is a y1, and x is related to y, and x is also related to y1. So this will not happen in function, then that is not a function. So that's why we have written for every element a in a or x in a, it belongs to precisely one pair a comma b. So this x must belong to one pair, that is x and y, and not the other. So that is to be noted for function. And if these are the two elements in function, that means x is related to y, then we say y is the image of x under f, and the set A is called domain. So this is domain, and this may also be called as codomain, but we define range of function. Range of function f is the set B belongs to B such that B is equal to f of A for some A belongs to A. So that means if there are certain elements, so in place of x and y, if you consider A and B, suppose A1 is having image as B1 under F, A2 is having image B2 under F, A3 is having image B3, and so on. So then this set B1, B2, B3 is called the range of this function F. So all B belongs to this B such that B is equal to image of some A from the set, first set A, then that is called the range. So this is B1, B2, B3 is the range. If there is an element B4 but it has no inverse image here, so or pre-image here, then that will not be in the range. So this range here is exactly B1, B2, B3, and which is subset of B. It may contain more elements which are not having related to any element from A. So thus the range of F is the subset of B consisting of all images. So these are all images, and but this is not an image of an element. So this is not, B4 is not in the range of F. So only B1, B2, B3 will be in the range of F, and such a function is also called a mapping. So we call function as a mapping of A into B. Now further, if C is subset of B, then inverse image of C under F is denoted by F inverse of C. So and that is defined as A belongs to A such that f of A belongs to C. So what will be the, so this set is called image set. These are images, and these are called inverse images. So thus this B1, B2, B3 are images, and if you consider this as the set C, so if I consider C as B1, B2, B3, then what will be F inverse of C? Inverse images of these elements B1, B2, B3, that will be those A belongs to A such that f of A is in this set C, and this is the inverse image, means A1. So that will be A1, A2, A3. So thus the inverse images of these three elements are these, that is A1, A2, A3, and that is the meaning of F inverse of C if this set is C. Likewise, if D is subset of A, so this is a subset of A, and the set f of D is called image of D under F. So if I consider now D as say, so I shall write here if I take D as, suppose D is equal to A1, A2, then what will be f of D? That is image set of this D. So f of D is defined as fx, x belongs to D. That means a set of images of these elements will be f of D, and that will be actually f of A1 comma f of A2. But we can see what is f of A1. F of A1 is B1. A1 is related to B1. So therefore this will be set B1 comma B2. So that is the meaning of image. So this image set will be subset of B, and inverse image set will be subset of A. So this is the meaning of function or definition of function. It is a subset of order pairs A cross B, but not all subsets of order pair A and B will be functions. Only the condition is each A belongs to A belongs to exactly one pair AB. Such order pairs will form a function. So if we have A is this type of relation, say A comma 1 and A comma 2. So this is order pair, but this will not give a function, or these two will not be the relation in functions, because here A is related to 1 and A is also related to 2. So such thing will not happen in function. That is to be noted. And now we will consider an example of this. For example, let f be a function from set A to B, and that set can be defined, A to B, defined by f of x is equal to x square. And what is the condition here is this x is minus infinity is a real number, and then what will be x square? We know that square of real number is non-negative, and therefore its range will be non-negative, means 0 to infinity. So thus here A will be, therefore A is the set of whole real numbers from minus infinity to infinity, but the range is, or this domain can be considered as a real number, but f of B, f of A will be equal to 0 to infinity. Non-negative real numbers, because it is a square, and a range is a square, means the number is, real number is non-negative. And for this function, say if we consider this as A, which is equal to R, and B may be equal to R, but its range is subset of this B, and that the elements are, this is infinity to negative infinity, and say 0 is there, and here also we can consider the infinity to negative infinity, 0. But we know that 0 square, the image of 0 is 0, and see, but what is the image of minus 1? The image of minus 1 square, that is plus 1, and therefore it will be 1 here. So image of minus 1 is again 1, and image of 2 or image of 1 is also equal to 1, and thus here the image of minus 1 and 1 is the same. So this may happen. So many elements from set A may be related to one element in this set, but the reverse will not happen. That means one element cannot be related to many elements in this set B. So here what we will have is f of minus 1 is 1, f image. So here the function is defined as f of x is equal to x square. So therefore f of minus 1 is minus 1 square is equal to 1. F of 1 is 1 square, that is equal to 1. And therefore we may have f image of this set minus 1 comma 1, and that is equal to 1 only. So likewise we can write f inverse of, so from this inverse image of 1, f inverse of 1 is equal to, it has two, see, inverse image of 1 will have two elements in set A, that is minus 1 and 1. So it is minus 1, 1. And what will be f of say minus 1 comma 2, or we can say closed interval from minus 1 to 2. See, here is minus 1, here is 1, and if you consider here as 2, then the image of 2 will be 2 square, that is 4, somewhere here. And thus the elements from minus 1 to 2 will be mapped from 1 to 4, because we know this square of minus 1 is, the square of minus 1 is 1, but 0 is there here, and therefore square of 0 is 0, and thus it will be from 0 to 4. You note this, minus 1 square is 1, 0 square is 0, and then 1 square is again 1, 2 square is 4. So it will be between 0 to 4. So this is f of f image of minus closed interval minus 1 to 2 is closed interval 0 to 4. And likewise the inverse image of 0, 4 will be equal to minus 1, 2 under this mapping. So what is the range of here? Range of f is the positive or non-negative real numbers. Range of f is equal to 0 to infinity. See, only this 0, or see, I should have to write this. See, this we have written 0 to minus infinity. So 1 will be at the positive side and 4 will be here. So you please note this, and we have to correct it. So these arrows are to be corrected. So this upward direction we shall consider positive, and downward we shall consider negative. So again, see, or we can change the upward as negative and downward as positive. See, this is a 0, it is a positive direction, and that means 1 will be here, minus 1 will be here, and 2 will be which element we have considered 2. And see, image of 0 is 0, image of minus 1 is 1, image of 1 is again 1, and image of 2 is 4. Now so this will be the corrected figure. What we have done earlier was the interchange of positive and negative real numbers. So this I have denoted this as positive and the downward as negative, as we denote for y-axis, and thus these will be the images. That is image of minus 1 and 1 is 1, minus 1 and 1, that is 1, and then f inverse of 1 will be minus 1 and 1, and image of this closed interval. So these are discrete, means only two elements are there, but here all real numbers from minus 1 to 2. All real numbers from minus 1 to 2 will be mapped between 0 and 4. So, and inverse image of 0 and 4, the interval 0 to 4 will be the interval, closed interval minus 1 to 2. So that is to be noted. So please note this figure again. So this is an example of function. Here we have considered that images, then inverse image of a set also. Now further we will study the types of functions. Now we shall study some important types of functions. So I have also written the definition here. First is a function f from a to b is said to be 1 to 1 or 1 1, or it is also said to be injective function if each x belongs to a has exactly one image in the range. So that means one element or two element will not have the same image. That is the meaning of 1 1 function, or in other words, it is for x1 and x2 are in the range that is domain A, x1 comma x2 belongs to A, then f of x1 is equal to f of x2 implies x1 is equal to x2. That means if the images are equal, then the inverse images will also be equal. So that is the meaning of 1-1 function. That is one-to-one mapping. Every element is related to unique element, and also conversely. So images are equal, then their inverse images are equal. Or in other words, if x1 is not equal to x2, then f of x1 is also not equal to f of x2. Such type of function is said to be 1-1 function. So for example, if we have this function, say f of x is equal to x square, that function we have considered earlier, then whether it is 1-1. So we have, suppose the set of real numbers, a is a real number and b is also real number, and this is the function that we have seen earlier, f of x is equal to x square. Here this function has this is real number line 0 and 1 minus 1. So what is the image of -1 we have seen is 1, and image of 1 is also 1. So 1 is related to 1 and -1 is also related to 1. So this function is not 1-1 because we have f of 1 is equal to f of -1. But this does not imply 1 is equal to -1. So this is not a one-to-one function because these two elements are having the same image, that is 1. So if image of every element is distinct and conversely, then the function is said to be a 1-1. Or for example, if you consider f of x is equal to say 3x plus 1, then this function will be 1-1. Because if by this definition, if you consider f of x1 is equal to f of x2, then what that will imply, f of x1 will be 3x1 plus 1 and f of x2 will be 3x2 plus 1. Here now we can cancel 1 from both sides, and this gives 3x1 is equal to 3x2, and dividing by 3 we will get x1 is equal to x2. So therefore the function defined by this relation f of x is equal to 3x plus 1 is 1-1. So this is the important condition or criteria for one-to-one function. So the result is f of x1 is equal to f of x2 must imply x1 is equal to x2, where x1 x2 are in the domain. So this is an example of 1-1 function, but this is not 1-1 function, because if you write f of x1 is equal to f of so for fx is equal to x square, then what we will have, f of x1 is equal to f of x2. This will imply x1 square is equal to x2 square, but this doesn't imply x1 is equal to x2, because this if you take the root, then x1 will have the possibility of plus or minus, and therefore this does not imply x1 is equal to x2. x1 here we can have x1 is plus 1 x2 or minus x2 maybe, and as like this we have 1 square is 1 minus 1 square is 1, and if you take the square root, then 1 we get 1 is equal to plus 1 or minus 1. 1 is equal to 1 is right, but 1 is not equal to minus 1. So this implies that does not imply, or actually 1 is not equal to minus 1, but f of 1 is equal to f of minus 1, but 1 is not equal to minus 1, and therefore this function is not 1-1, this is 1-1 function. So that is the meaning of 1-1 function, and this is the criteria or condition for 1-1 function. Next we shall see what is onto function. A function f from a to b is said to be onto, or which is also known as surjective, if for every y belongs to b there is an element x belongs to a such that f of x is equal to y. That means every element in B set has inverse image, then the function is said to be onto. So if we consider this set function as AB from A to B, and if we have element y here, then that element y for every y, so this must happen for every element in B. Every element in B there is an element x in A such that, or some element in A such that f of x is equal to y. So for this y we will have x here, or if you consider y1, then x1 will be the inverse image of y1. If there is y2, then its inverse image may be considered as x2, and so on. But if there is some element y3 which don't have the inverse image in A, then that function will not be onto. If this will be a function but it will not be onto, its range is y1, y2, and y3 is having no inverse image, then it will not be onto. And if every element, and if we consider y3, the inverse element is x3, then this becomes onto. So the condition is for every y in B there exists x in A such that f of x is equal to y. That type of function is said to be onto function. So these are two important types of function, which is 1, 1 and onto. Now we shall further define inverse function. So this is defined for only f is 1, 1. So that is also to be noted. If f is a function from A to B and f is 1 to 1, then the function f inverse called the inverse function of f, and it will be from B to A. Inverse will be from B to A. For inverse, B will be the domain. B to A is defined as follows: f of x is equal to y, then f inverse of y is equal to x, like this. So if this is the function f from A to B, then its inverse will be from B to A. And you see, we have f of x1 is equal to y1. So therefore f inverse of y1 is equal to x1. F of x2 is y2. Therefore f inverse of y2 will be x2, and so on. So this is the relation that we have to remember. This implies and implied by f inverse of y is equal to x. So if f of x is y, then if we shift this operator on this side, that becomes inverse. F inverse of y is equal to x. And also we should note that, see, we have for this function f of f inverse of y, that is equal to y, and f inverse of f of x, and that is equal to x. Now how it is so? You can verify from this. What is f inverse of y? That is x, and f of x is y. So that means composition of function and its inverse will be cancelled, and we get the same element in this both way, f into f inverse or f inverse into f. So that is composition of f and f its inverse gives the identity function actually, and that the effect cancels here and we get the original element. F inverse of f of x. What is f of x? That is y, and f inverse of y is x, and thus, so this is the meaning of inverse function. We have seen 1, 1 function, onto function, and inverse function, and the relations that we should remember for these functions. So remaining part we will continue in our next lecture. Thank you.